things I want to point out to you is on your Canopy account, I know this is a different class, this is for applied calculus, but it's the same for you folks as well. Okay? On your Canopy account, if you go to the My Math Lab tab, it'll take you to this page I'm on right now. Is that looking familiar to everybody? When you're on that page, if you click the My Lab and Mastering Course Home, okay, and let's see here. On the left-hand side, there is a tab that says, ooh, look at this, study plan. Really? A study plan. Now remember, right now I'm in a calculus, not the college algebra, because that's what I just had to do from the last class. Same thing works. You click the study plan, and you come up with a couple of options, recommendations, progress. Let's just go with all chapters. And for you folks, what chapter are we in right now? We're in chapter 2. So if we go with chapter 2, okay, it'll give you some stuff. Now, do these particular subjects match with what we're doing? The answer is no, because this is in a calculus. But chapter 2 for you is going to say linear equations. Then for any particular section you go to, it'll bring up questions, a series of questions from that particular section. Okay? So, you remember your problems in the My Math Lab stuff? Same idea here. It'll pull up problems, allow you to study, allow you to practice, give you feedback on if the answer is right or wrong. But what this will do is under this study plan, it'll allow you to chapter and section choice to study whatever you want to study. Yeah.
Is it correct that we can go back and redo the problems that we've done in the past?
To tell you the truth, I'm not certain. I've never tried to go back and review them.
Yeah, I tried doing it. You can't do it.
Try doing it. You can't. I've gotten the impression that you can.
Okay.
But that's why I'm pointing this out. Now, there are a couple of ways that you can get back to doing some additional work or something or other to try and get ready for the test. One of them is go to this study plan. The other is to go directly to the book, and the book is the eText Contents. And when you go there, you're allowed, you know how to work in that, right? And with each section, remember, with each section, you have homework problems. Oh, that's right. So at the end of each of the sections, you can just go to the section you want to work on, and there are homework problems there as well. So there are a lot of problems for you to work on. You've got the study plan section where you can do problems, enter answers, and they'll give you feedback. You've got the textbook itself where you do problems. Okay? And then way in the back of the book, it has the solutions. And so there are a lot of directions to go. If you want to talk to a real human being, what are some directions to go for a real life human being? Okay, yeah, swing by office hours for me or the math lab. I don't know if you call me a real life human being or not, but okay. But yeah, there are a couple of opportunities there for you to work with folks as well and get you in good shape for this coming test. Yeah. You know where the main computer concourse is? Okay.
Oh, it's in like the little computer lab.
Yeah, you go in the computer room, and it's that long, thin room, way at the back, kind of in the middle. 112G is in golf, is where the math lab is. Okay? Yeah.
So is this test over everything from the beginning?
Yep.
Okay.
It's over everything from day 1 up through chapter 2.
So from first day of class.
Yeah, from the first day of class on up. Whoa.
Man.
Yeah, it's going to be a brainful, isn't it? Okay.
How many questions?
Usually about 4 pages. Now, I know that didn't answer your question of how many questions. I'm not certain. It depends on how things get broken up. You know, number 1 part A, B, C, D, F, G, or number 1, 2, 3, 4, 5. But it'll be about 4 pages long. And there will, of course, be space for you to work the problems. Okay? The problems will be very similar to what the quizzes have looked like. They'll be very similar to what the homework problems have looked like. I do my level best to not do anything surprising or, whoa, we've never seen that, or where'd that come from? Okay? Yeah, well, it was a footnote at the bottom of page 137. Yeah, that's not going to happen in here. Okay? I try and keep it real straightforward and no surprises. Just be able to do the stuff that you need to be able to do. Everybody good? Make sense? Okay, so let's close a few of these. My daughter wants to go someplace nice for a dinner. She and I have never gone out anywhere nice. Gentlemen, if you're looking for something nice, BB Riverboats is not bad, especially this time of the year. And if you can't afford the dinner, they've just got one where they've just got music and stuff, and you're just riding up and down the river. Anyway, so there are some less expensive ways to do this stuff. It's cool. Okay, let's jump into first a couple of problems from the last section in chapter 2 to make sure that that's working for you. Then from there, we'll jump into chapter 3.1. When we hit 3.1, in your notes, if you want, just draw a line and say, test 2 begins here. Because chapter 3 marks material that will be on test 2, not test 1. Okay? So let's do a couple of examples first. Just make some stuff up. Let's say we have something like the absolute value of 3x minus 7 has to be greater than or equal to 4. How do you do that? Yes, sir.
I'll start by plus 7.
Please.
Plus 7 on both sides, but first, before you do that, you want to take away the absolute.
That's right. Yeah, we got to figure out some way first to get rid of the absolute values, then do the plus 7. So you've laid out all kinds of information for us. Way to go. So the first thing that's going to happen is we're going to write this as 3x minus 7 has to be greater than or equal to 4. Right.
So, and then the next one will be 3x minus 7 less than negative 4.
Right. Less than or equal to negative 4. The idea behind it being less than or equal to on the other side, way to go, you got it all nailed down. Think back to a number line. Here's 0, here's 4. By being greater than or equal to 4, what that's really saying is, hey, we've got to be at least this far away from 0. That's what that's really saying. With the absolute value, negative 4 comes out the same as positive 4, doesn't it? Okay? So to be at least that far away from 0 would also mean that we could be on this side, but we've got to be the same distance away on that side. Which would mean we have to be at negative 4, or as you move to the left, are you getting into bigger numbers or littler numbers? Smaller numbers. That's where this second inequality comes from. Does that make sense to everybody? Okay? Everybody good? Okay, so we've got these two inequalities we have to solve, and as Myron said, first step is break it into two pieces like this so that we know what directions we're heading. Secondly, solve them. Well, in this case, what we're going to do is we're going to add 7 to each side, and that'll then give us this 3x is greater than or equal to 11. Divide by 3, and we get 11/3. Now, when we divide by 3, do we need to flip the inequality? No, you only flip it when you multiply or divide by a negative. Yeah, if it's a positive number, it's all good. For the second part of this, we're going to add 7 once again. And notice when you're adding 7, we don't even think about flipping the inequality. It's only if you multiply or divide. what this will give us then is this 3x less than or equal to 3. Everybody good with that? Which then gives us x less than or equal to 1. To visualize what the solution set to this looks like, okay, let's see, 1 is, let's put 1 here. 11/3 is close to being what? Well, what's 12/3? 4. So this is pretty close to 4, isn't it? So it's going to be over to the right of 1. So we're going to have our 11/3 over here. Then what's going to wind up happening is, from 1, we want to go bigger or smaller? We want to go smaller, don't we? And can we equal 1? Yeah, we can equal 1. So what we're going to do is we're going to go smaller or equal to 1. On the 11/3, once again, we can equal it or go bigger. Oftentimes, drawing it out on a number line makes it safer for writing out the answer in set notation, because then you just start from left to right on the number line. Well, let's see here. Starting at negative infinity, we can go over to 1, and we can include the 1. Does that make sense? Along with that, we've got this other chunk where we can go from 11/3 over to infinity. Does that make sense how I use the number line to help lay out how the answer is going to be written? Yeah.
I was gonna say, for me, it makes sense because, like, on the left, how you got that negative infinity,
Uh-huh.
and then we go towards left on number line, it's all negatives. So
That's
it's
right.
positive, and then,
Yeah.
yeah, and it's positive on the right, and then you got the positive infinity.
That's right.
That's why I say the union, like, what you explained to me, like,
Yeah, that's the middle gappy part there.
that's the gap.
Yep.
Okay.
What the union actually means is we're going to use this chunk along with this other chunk. Yeah, I'm glad that's working. It always worked well for me to be able to see it and write down the different chunks. Okay, I'm hoping that'll be useful to you. Okay, so here's the solution to this one. The solution is x is an element of that set of values. X belongs to something or other in either of those two chunks. Okay, so here's a scenario where you have an absolute value and a number on the other side. What on earth happens if you have something like this? Let's say the absolute value of 2x plus 8 has to be less than or equal to the absolute value of x minus 4. Ooh, that doesn't look very nice. Well, we're going to play the game exactly the same as Myron laid it out in the last one. What we're going to do is we're going to write down, first off, we have our 2x plus 8 less than or equal to our x minus 4. Then the second part of this is going to be, we're going to have our 2x plus 8. It's going to be greater than or equal to the negative of x minus 4. Do you see how it parallels the earlier one? If you look in the upper right-hand corner, we flipped the inequality, and we made the right-hand side negative, didn't we? Same deal here. It works the same. It's just that you got an extra set of absolute value signs, and it's okay. It doesn't change things up. Hey, at this point, is the algebra pretty easy to handle either way? Yeah. If we subtract an x from each side, we're going to get x less than or equal to, and we're also going to subtract 8 from each side. So we're going to do a couple of things here. and we're going to get negative 12. So x has to be smaller than negative 12. There's one answer. Now in the second one, I'm going to have to distribute this negative sign first to figure out what's going on here. Minus x plus 4. Wait a minute, I miscopied that. That should be 2x plus 8. 2x plus 8. Everybody okay so far? Then we're going to do the same moves that we did before. First we're going to add an x to each side. And we're going to subtract an 8 from each side. And what we're going to get here is 3x greater than or equal to what? Negative 4. And x is greater than or equal to a negative 4/3. Is everybody okay? Yeah.
How did you turn it to a positive 4? X plus 4.
What I did was to distribute that negative sign. See it's negative here?
Yeah.
Took it times that.
Okay,
Yeah, that's going to change it up some. Now, we're back to the same point that we were in the last one. We've got two different directions for x. How am I going to write the answer? And very truthfully, even when nobody's looking, when I'm not in front of class or trying to demonstrate it for folks, I usually just draw out a number line because it's an easy way to work with this stuff. If you've got a negative 12, let's see, negative 4/3. On the negative 12 side of this, do we want numbers that are bigger or smaller than negative 12? Smaller, right? Because it says x is smaller than negative 12. Okay? But you're allowed to equal it too, so I'm going to use a solid dot there and go in a direction that's smaller. Be careful. Negative 11 is bigger than negative 12. Okay? Sometimes people get that mixed up. Then over here, we want to be at a negative 4/3 or bigger, greater than. So we can start the negative 4/3 because it's greater than equal to, and go that way. Everybody good? Which is kind of cool because once again we've got our number line all laid out, and then going from left to right here, hey, look at there, we can just copy this down. Negative infinity to negative 12, and along with that we can go from a negative 4/3 to positive infinity. And that's what x is an element of.
You always have to say x is an element of to get the answer right.
There are a variety of ways of doing it. This is one of them.
So you don't have to say it.
Right. Yeah.
Since you did the absolute values of x minus 4, wouldn't we need to do the absolute values of 2x plus 8?
Yeah, don't we have to do the negatives on the left-hand side? And the answer is yes, we do. Technically, we've got to first treat the left-hand side as our absolute value and deal with the right-hand side positive and negative. Then we would have to treat the right-hand side as the good guys and the left-hand side as positive or negative. But the fact of the matter is, by the time you get done, those other two wind up being one of these two cases. So with two cases, it covers all four options. You're right. You do need to do it the other way as well. But it's kind of folded right in there. How about that?
Oh yeah. So I got a question. Like say, you know how the 2x plus 8 positive.
Yeah.
Say that was negative. Will we still be able to do that absolute value?
If which was negative?
But the 2 and the 8 is down like negative 2x plus
Yeah. So if you had something like a negative 2x minus 8 and greater than or equal to x minus 4 or something like that,
Yeah.
yeah, you'd still have to do this.
Oh.
Now, one of the things that will sometimes happen is when you lay out your number line, the one of them, I'm making up some numbers now. Okay, this doesn't pertain to any particular problem. But let's say this is 3, and let's say this is -5. What you have seen are two of them where they go in opposite directions. Sometimes they're going to go like this. If they go like that, where are the answers that work? And it's kind of tricky. We know that if we pick them over here, it's going to work for one but not the other, don't we? So that doesn't really work. Okay? Becky wants to go to Red Lobster. Chuck's allergic to seafood. That's not going to work. Okay? That's right. Yeah, because we know that this side isn't going to work either, is it? But, see this center part? Everybody's happy with that answer. Okay? Becky says Red Lobster. Chuck says, might as well call the ambulance right now. Just have them meet us there. Okay? Because my throat swells shut. I can't breathe. I pass out. You know, all kinds of great things happen. On the other hand, I offer, I don't know, whatever, over on the right-hand side, and Becky says, yeah, well, that's just as good as Red Lobster. So we can those two, and we finally decide on something in the middle, whatever that might be. Okay. Did you note this weekend is some of the Oktoberfest stuff in Cincinnati? A bunch of the German-American societies are getting together from like Ohio, Kentucky, Indiana. And I've not been to it. I heard them talking about it on the radio. Sounds like lots of good food. So if you're looking for something, it's supposed to be gorgeous Saturday. Get some nuts or brats, pastries. Anyway, gotta get my mind back on this stuff now. Okay, so does this make sense on how you can also wind up with a center section? If you wind up with that center section, what is your solution going to look like here? Your x is just going to have that interval where it works. It's just going to have one interval now. You don't need the union sign. Does that make sense to everybody? Okay. So there's that. So we got a couple of them taking a look at here. The first one, the situation where you just have one absolute value. The second one, a situation where you have two absolute values. Okay? And in the two absolute value situation, should be 4 cases, but 2 of them are duplicates of the other, so you just have to work 2 situations out. Which I kind of like. Saves a lot of work. Okay? Does that make sense? Okay, so what we've been working with here is, in this chapter 1, things that are linear or have linear components to them. Absolute values have linear components to them. Each side of the graph is just a line, isn't it? We talked about how you deal with lines. Not all data is going to look like a line. Okay? You know that, and I know that both. Okay, so if we got some data, one of them that comes to mind to me, okay, as far as data where it's quadratic, is something like the following. Now, just in case you're thinking, where are we? This may be where you want to put these lines and test 1 ends here. I don't know how you do your notes. I always used to do my notes like that, so I knew exactly where test 1 ended, instead of, gosh, how far do I study? How far do I study? And I got some of my old notes laying around. Kids found some of them, and geez, it really does have those little things drawn right in there. Okay, we're headed into chapter 3. A couple years ago, I was asked to speak out in Phoenix, Arizona. Found out then and there I don't like deserts. They're hot, they're dusty, they're dry. And then the sun comes up. And they go from hot to hot and worse. Okay? One of the things that's kind of intriguing, though, with regard to a situation like that, is, I don't know, let's see if this will, eventually maybe I'll get this to work. Oh, look at there. It did. Okay, so we'll call this time. Okay, time of day. And minutes until sunburn. At 8 o'clock in the morning, you're very concerned about a sunburn? Not really. Not even out in the desert. Maybe a snake bite, but not a sunburn. However, by 2 in the afternoon, what's starting to happen? Things are cooking pretty good out there, aren't they? So on this time of day stuff, if we had like 8 a.m., and then here was noon, and here was 4 p.m., and here's 8 p.m., okay, we could look at how many minutes you could be out in the sun before you got a sunburn. Now this is assuming no suntan lotion or any form of protection on your skin. Okay, 8 a.m., you could be out for hours. It would take hours of exposure at that level of sunlight. Okay, so I'm making up something here. Let's say it's about 2 hours. Well, this actually says minutes, so 120 minutes. This will be 60 minutes. Okay, so at 8 in the morning, no worries. By noon, yeah, well, you can start to get a sunburn there. But by 4 in the afternoon, do you really want to be out there in that direct sunlight without any sunscreen or anything on, or are you going to be roasted? Okay? You're going to be cooked in a variety of ways. It really is down into a matter of minutes. And that's not just for fair-skinned people like me. I mean, it is a matter of minutes, 5 to 10 minutes, and you're roasted. Okay? As 8 p.m. rolls back in, the amount of exposure increases. And what you wind up with then is, if you look at how the data are shaped, you legitimately do get a quadratic. What we're going to look at in Chapter 3 is how do you work with quadratics, because they are another way to fit data. Okay? There are a variety of other examples. Lots of them have to do with things being thrown or dropped, stuff like that. I'll show you in a little after a while here, hopefully. When we were out in the Badlands a couple years ago, the kids and I don't know about you, I love to go up to the edges, you know, on those cliffs, and you're, oh my gosh, whoa, look, is that scary or what? Yeah, I'm scared. This is really scary. And my wife's back there about 40 feet. Get away, you idiots, get away. What if one of us falls? And I turn around and say, there's more money for you for dinner. She was not happy. But the kids and I are there. Get the kids away. Get the kids. They are. Look, they're 6 inches back. They're fine. Okay? I mean, how many of you should just stand in here and fall over? Well, what difference does it make what's happening 6 inches in front of you? Okay? And they wanted to know, well, gosh, how far down is it there? I said, well, I don't know, but we can figure this out. And I'll show you either after a while or Monday how you can figure out how far down it is. Don't do this at Kings Island. Too many people around. Okay? But at that cliff, there was nobody for probably a half a mile. So it was safe to do. So quadratics are useful in a lot of different situations. If you recall, with linear equations and with some of the other things that we've looked at, I'm kind of excited about this now. We started out by looking at how they graph. Look at there. Okay, so we got a graph. With a quadratic, it graphs exactly the same. Let's say that we have something like y equals, and I'm just making something up, x minus 3 squared plus 4. Do you remember back when we were doing things like the absolute value and graphing those, how the number inside told us if we shift left or right. And the number outside told us what? Up or down. So what this says is we're going to go left or right 3 units. We're going to go to the right because a positive 3 will cause that to zero out, won't it? Okay, so we can go over to the right 3. 1, 2, 3. And then, well, I don't know if I want to do that. There we go. And then we want to go up 4. 1, 2, 3, 4. And that's going to be the point where the vertex is. Now, what's the general shape of a quadratic? It's a U. It's a parabola, isn't it? That's okay if you didn't remember. That's why you're here. If we look at the leading coefficient, the number in front there, that tells us it opens up because it's positive. So the shape of this thing is just going to be kind of a U-shaped or a parabola like that. Does that make sense to everybody? If we do something like this, let's say we have something like y equals 1/2 x plus 2 squared minus 1. The first thing we're going to do is we're going to realize it's a quadratic, so it's going to be a parabola, kind of a U-shaped. What's the x plus 2 tell us about the vertex? To the left, 2 units. 1, 2. What's the negative 1 tell us? We're going down, aren't we? We go down 1. Our vertex is going to be at -2, -1. We look up front, it's positive, so the U or the parabola is going to open up. But, do you see it's a 1/2? That's going to make the y value smaller, isn't it? They're not going to get big as fast. So what that does is it kind of flares out, flattens out the parabola like that. Does that make sense? I'm getting real confident with this thing now. And it didn't work. By the time I get confident, it blows up. Okay, let's take something like this. Let's say we have something like y equals a -3 x plus 1 squared. Let's say plus 2. I'm just making up numbers. First thing, we want to get the vertex positioned. The x plus 1 squared is going to be left or right? To the left 1, and the plus 2 says to go up 2. So you put a dot there, and there's your vertex. We know it's a parabola because it's squared. Is this particular parabola going to open up, or is it going to open down? It's going to open down, you're right. How'd you know that? Yeah. The negative means it's going to open down. What's the 3 going to do? Is it going to make it flare out or make it skinnier? It's going to make it skinnier because the values are going to get big faster. Okay, so instead of, if we originally would have had x11, x1/2 would put it down here and things would be moving slower. At x13, it's going to put it up here where things are going, oh yeah, it's getting steep faster. Does that make sense to everybody? So if the number is bigger than 1, it's going to make it skinnier. If the number is between 0 and 1, it's going to make it flatter. This is going to open down and it's going to be skinny. How skinny? I don't know. We'll just make it obviously skinnier than what some of the other things have been. And there you have it. This is also pretty cool because for not everything. You can't tune in the whole deal on it. Okay, so it's not going to cooperate at the moment. Maybe we can get it to cooperate now. There we go. Let's say that you have a parabola like this. You cannot perfectly come up with the equation for this, but you can do a whole lot of it. First off, is this linear? Well, clearly not, Chuck. This is a parabola, so it's going to be an x squared thing, isn't it? Aha, yes, I'm going to need something rather squared. Now, this vertex is at 4, -2. The 4 and the -2 clue you into some real important information in the equation that we're building. Where's that 4 wind up landing in the equation? Inside the parentheses. So we're going to have x plus 4 or x minus 4? X minus 4. We're just kind of thinking backwards to the way we were a minute ago, aren't we? How about this y value here? What's that going to look like? -2. Now, we can kind of guess what's going on out front here. We know for sure it's going to be positive or negative? Positive. Is that value in front, that leading coefficient, going to be larger than 1 or between 0 and 1? Larger. It's going to be something like 2 or 3 or something like that, isn't it? Does that make sense? So just by looking at a graph now, with some of that information, the same moves that we've used in the previous sections, you can get a whole lot done, can't you? You can get a whole lot of information really quickly. Okay, is everybody good with this? It's actually kind of neat how fast. Did you ever figure that you'd be able to walk up to an equation and that quickly just draw a picture of it and ta-da, you're done? With something like this, this is a new one. If you had something like that on a quiz or a test, would that be easy points if I said just hand draw a sketch of that? Yeah, that's real easy now, isn't it? I mean, you can think about this and say, okay, we're going to go, let's see, where's the vertex going to be? It's going to be to the left or the right? To the right 3, and up or down? Up 5. So there we go, there's the vertex. Is this thing opening up or down? It's opening down. Is it going to be flattened out or real thin or just normal? It's going to be kind of flat. Ta-da! And realistically, for a lot of you, we don't even have to have that conversation. You're doing it in your head a lot faster than that. You just look at it, gulp, draw it, and boom, you're done. You can graph these things faster by hand than with the calculators. You can have a graph before I can get my calculator out and turned on. Literally. That's pretty cool. Okay? Now, on some of these, or at least I get a kick out of it, calculators are slow, you know, they take too long. Okay. So, where are we going to go from here? Well, one of the things that we need to realize is it's really nice to have this in a form, something like x plus 4 squared minus 2. That's nice, isn't it? Because all kinds of information falls out at your feet. But the catch is, geez, here it comes again. There's always a catch. Okay? Things usually come to us like this. 2x squared minus 6x plus 7. Isn't that usually the way the stuff works? We're dealt something like that. What I'm going to show you how to do here is how to take something like this and convert it to this other form. Once you got it in this other form, man, you own that equation once it's in the other form, don't you? Okay, you know exactly what's going on. So how are we going to do this? Well, what we're going to do is we're going to say, okay, we want to have something squared. And it's okay to have some kind of a number out front here, some kind of a leading coefficient, and then plus or minus some kind of a different number over here. Does everybody buy that? We want to get this thing so there's something squared in the middle of it. That's kind of the foundation of the whole deal. Well, the way we're going to do that is going to take the 2, factor it out of part of this, and then we're going to throw the plus 7 out back in the backyard or out in the garage or wherever you throw things that you're trying to get out of the way. Okay. Where'd the 6 go? Yeah, what happened to the 6? I factored it out. If we take this 2 and distribute it, we'll get a 2x squared, and we'll get a what? Yeah, so we factored it out. It's still there. It's just kind of buried. Okay, but that's okay. You know it's there. Now, have you ever completed the square before? Say, what? Complete the square? Yeah, I complete the square all the time. There are 3 sides. I draw on the 4th one. I completed the square. Okay? What completing the square actually refers to is coming up with a number here so that we can rewrite all that stuff inside the brackets in a notation like this. We're going to rig it. We're going to rig this thing. The way you rig it is you come up to whatever this coefficient is here. You divide it by 2. You take half of it. And then you square it. Which in this case will give us 9 over 4. Okay. What you want to do is take whatever this coefficient here is, and we can go through why. It's not like it's beyond you or anything. It's just that, wow, we've only got about 8 minutes left, and I don't want to spend those 8 minutes on that. Okay? So don't worry about it. It's not some huge, nasty math that Einstein came up with and 3 other people in the world understand why. Okay? It's not that at all. It's we're down to 7 minutes. You take whatever that coefficient is, divide it by 2. And once you've got it divided by 2, you square it, and it goes in there.
Did you divide it by 2 because that was what the first number was?
Nope. You always divide by 2 regardless. Yep. No matter what the coefficient is. Even if it's pi out front, see that 2? What if that was pi that was factored out? We'd still divide by 2. Yeah, that's good. Wait a minute. Is that okay? So the 2 that we divided by has nothing to do with our lead coefficient. Okay. Now, what we've just done is we've added some amount, haven't we? We walked up to this equation and we put something new into it. If you put something new into it, is it the same function that it was before, or is it something different now? It's something different. So when we add something, we have to compensate for adding something by subtracting the same amount. So way over here on the right-hand side, I'm going to subtract. I'm skipping a space here. There's a space being skipped there. And I'm going to put minus this 9/4. If I add it and subtract it, have I really changed the equation? Okay, it's like saying, hey Chuck, good news, you got a $50 raise, but we got to cut your salary $50. What was even the point of having this conversation? Because in the end, am I anywhere different than I was at the start? No. So that's the idea here with subtracting this 9/4. But we got to be careful, because you see this 9/4 is sitting inside, so along with the x squared and the minus 3x, what else gets multiplied by 9/4? The 2 is going to multiply the 9/4, isn't it? I'm sorry, not what else gets multiplied by 9/4. What else gets multiplied by 2? Please? So, yeah, the x squared is going to get it, the negative 3 is going to get it, and this 9/4 that we just built is going to get it. So that means that we've got to, when we're adjusting way over to the right, we've got to do the adjusted number. And the adjusted number also has that times 2. Does that make sense? Okay, so now that we've got this, equals, I'm going to put a 2 here. We're going to come back to this stuff momentarily, but let's deal with what's sitting out back. What we have here is 7 minus 9/2. Does that make sense to everybody where 9/2 came from? 2 times 9 is what? 18. So it's really 18 over 4. Oh, 18 over 4 is what? 9 over 2. Let's see, 7 minus 9 over 2, that's the same thing as 14 over 2 minus 9 over 2, which is going to give you what? (14 minus 9 is 5. Does that make sense to everybody? So what we're going to have way over here to the right-hand side is sitting out there, we're going to have a 5 over 2. Now, the last thing we need to deal with here is what's inside of the brackets. And if you'll recall, we rigged that so that something special would happen. When you complete the square, when you do this move down here, it will always be the case that this will factor into x, whatever this is, plus or minus, then it's going to be the 3/2 squared. If you FOIL that out, you'll get the x squared minus 3x plus 9/4. So what we've done here is we have this x minus 3/2 squared, just kind of rewriting things a bit so it's a little closer to what it would normally look like, plus 5/2. Hey, is that something easy enough to draw a picture of? Hopefully pretty easy. We're back into that form we'd hoped for, aren't we? Okay. This section in here, okay, is called completing the square. It's a handy little maneuver. It allows you to rewrite quadratics in this form. Just standing there, no calculator or anything. What is the vertex of this parabola? Well, let's see, the vertex is the nose of the thing, right? Well, are we going to shift it left or right? We're going to shift it to the right. How far? 3 over 2. So the x value is going to be the 3 over 2. We shifting it up or down? Up. How far? 5/2. There's the vertex. It's just that easy. Now, sometimes people will want to get fancy on you and ask things like, okay, well, you know so much. What's the line of symmetry? That's actually an easy question. Because if you think about this, what we have is this parabola opening like that, and the line of symmetry is going to be this line right down through the middle of it, isn't it? Where's that line going right down through the middle of it located? Isn't it the x value from your vertex? Do you see that? So the line of symmetry is going to be at x equals 3/2.
So the line of symmetry is always going to be the x value.
Uh-huh. Yeah, that's all there is to it. Really? Give me something hard. Okay, so if I give you something like a vertex of some parabola, and it's a -7, 5, the vertex, the line of symmetry, whoa, that's way too easy. It's going to be x equals what? -7. Does that make sense? I've posted homework for section 3.1. It's not due for a while, but over the weekend, if you want, you can start chipping away at it. Okay? Or work on that study plan, getting ready, because next Wednesday is a test. And I hope you get outside some this week. It's supposed to be gorgeous out. Take care. Oh, yeah. Thank you. A quiz, right? Man, without the quiz, you don't have the chance of an A. See, so here's a way to build up on your A for the semester. Pick up a copy. It's due on Monday.